Values of inverse trigonometric functions. Remember that trigonometric functions are periodic. Their values repeat over and over again. For example, if I want to look at the function f of x is sine x, I get this curve that continues in this up and down pattern over and over again. So because of that, there is no inverse defined for the sine function. In order to get around that, we restrict the domain of sine. That one's a little bit more easier to visualize. Let's see if I can actually draw that curve looking something resembling nice. There we go. We take the easiest region we can that contains all of the range of values sine can take on from -1 to 1, and we take the period or half period closest to the origin. In the case of sine, we take that value from negative pi over 2 to positive pi over 2. In the case of cosine, we take that range to be from 0 to pi. In the case of tangent, from negative pi over 2 to pi over 2. Cotangent goes from 0 to pi. Secant goes from 0 to pi. Cosecant goes from negative pi over 2 to pi over 2. And so we know how we are going to set things when we calculate a trigonometric or inverse trigonometric function. Coupling that with the values of trig functions at special angles, for theta equals 0, pi over 6, pi over 4, pi over 3, and pi over 2, we know that sine is 0, 1/2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2, which is 1. And then that same pattern repeats for the negative angles. Sine of negative pi over 6 is negative pi over 2. Sine of negative pi over 4 is negative root 2 over 2. And so because we know those values of sine, we can use the same pattern to calculate an inverse sine. So for example, the inverse sine of negative root 3 over 2. Well, root 3 over 2, which I somehow wrote as root 3 over 3 because I was talking and writing at the same time, right? Sine of pi over 3 is root 3 over 2. So the inverse sine of negative root 3 over 2 would be negative pi over 3, just working backwards. By a similar idea, if we want to look at y equals cosine of x, which has a period that starts at the top and comes down before continuing onward, we take these values for x between 0 and pi, y between -1 and 1, and again, same thing for the inverse cosine. So if we know the special angles for cosine, 0, pi over 6, pi over 4, pi over 3, and pi over 2 being 1, root 3 over 2, root 2 over 2, root 1, which is 1 over 2, and root 0, which is 0 over 2, which is still 0. Then we can work backwards and say that the inverse cosine of root 3 over 2 is pi over 6. And if we have a negative value, we have to do a little bit more work, but it's still well within the realm of possibility. If I want the inverse cosine of negative root 3 over 2, well, I know based on the cut that we've made for cosine, that that's going to be an angle somewhere between pi over 2 and pi, which means it's going to be an angle in the second quadrant, which is going to have a reference angle of pi over 6. And the angle in standard position, which has a reference angle of pi over 6, is pi minus pi over 6 which is 5 pi over 6.